Okay, we're gonna finish talking about parallelograms today. So get your notes out again, and got a couple more rules to cover, and then we're gonna do a study guide tomorrow, and your quiz is gonna be on Thursday this week. So if a quadrilateral is a parallelogram, we got two more rules that you're gonna work with today. Diagonals bisect each other. Diagonals bisect each other. And what that would look like in picture form All right, diagonals connect non-consecutive vertices. So if you take a line and you draw it from A to C, that's called a diagonal. And then if you take another segment or line and draw it from D to B, that's the second diagonal. And if the diagonals bisect each other, then this portion of this AC is congruent to the bottom portion of AC. All right, so I can add a vertex right here in the middle. We'll call this E. So A to E is going to be equal to E to C. Okay? Now both diagonals bisect each other. So D to E is going to be equal to E to B. And we'll apply this rule here in a minute or two and use that rule to solve some quadrilateral problems. All right, so diagonals bisect each other. The second rule, if a quadrilateral is a parallelogram, says that each diagonal separates the parallelogram into two congruent triangles. Each diagonal separates the parallelogram into two congruent triangles. So if you've got this parallelogram again, we're going to go with MNOP here. We're going to put a diagonal in here. And what we know about these parallelograms from yesterday is that this left side is equal to the right side, and the top is equal to the bottom. So now, these two triangles that were just formed by this diagonal are congruent to each other. So the congruent statement would be that triangle, we're going to go PMN, triangle PMN is congruent to triangle. All right, look, if we went P to M to N, we went across the side with one tick mark first. So it's going to be congruent to NOP. All right, those two triangles are congruent to each other. If I add this other diagonal from M to O, created two more triangles. We got a triangle here on the left bottom, and top right. So this triangle on the left bottom, all right, I'm going to call it OPM. Starting at O, going over here to P, and I'm ending at M, OPM. That triangle is going to be congruent to, if we went OPM, we got to go MNO. So MNO. Those two triangles are going to be congruent to each other. Everybody all right with that? All right, good, good. So let's use these rules now to answer some questions about a parallelogram. So we're going to find the value of the indicated variable. Find the value of each variable. And here we go. We got another parallelogram. And it is QRST. We're going to put in these two diagonals. And we're going to call this point of intersection in the middle here, this is point P. Q to T is 5x. RS is 27. P to R is y plus 4. T to P is 2y minus 5. This angle TSQ is 3z right down here. And we've got an angle up here, TQS, which is 95. And then just on the other side of that diagonal, we've got an angle that's 33 degrees. All right, so what I like to do is go in here now and fill in the information that we know. All right, I'm gonna say the left side is congruent to the right side. The top is congruent to the bottom. These diagonals bisect each other, so the 2y minus 5 is equal to the y plus 4. All right. all of these opposite angles are congruent. All right. So this angle right here is congruent to this angle up here. And this 33 angle is congruent to this 3Z angle. All right, so we're going to start off by solving for x. So if the left side is equal to the right side, then we got 5x equal to 27. Going to divide both sides by 5. And we get x equal to 2.4. For this y, we got 2y minus 5 equal to y plus 4. So we can subtract y from each side. And 2y minus y is y minus 5 is equal to positive 4. We can add 5 to each side. And we get a y that's equal to 9. All right, and then finally we got this 3z down here, this angle 3z, it's equal to the 33. So we take 3z, make it equal to 33. We divide both sides by 3. And we get z that's equal to 11. All right. Any questions on any of that? Using those two rules to find some side lengths, angle measures, and solve for variables. All right, so your practice problems for today are going to be page 407. Page 407, let's see, you got 4 and 5. Then over on the next page, looks like all you're going to have there is 17 and 20. And you got multiple variables to solve for in each of those problems. So let's do this, 409. 409, let's do 31 to 36. The assignment starts on page 407, but those are the problems that you need to get done today.